Hello everyone, my name is Kathan and today we will be discussing the problem Movie Festival 2 from the sorting and searching problems of the CSES problem set. Let's begin. Let me read out the question for you. In a movie festival, N movies will be shown. The movie club consists of K members who will be all attending the festival. You know the starting and ending time of each movie. What is the maximum total number of movies the club members can watch entirely if they act optimally? In other words, like two club members can watch two different movies at the same time, right? And if you remember the movie festival 1 question, this question is exactly similar to that question, but in that movie festival 1 this K was 1. The club only had one member, right? So he only had to watch all the movies, and the rule was he can watch a movie if the current movie's starting time is greater than equals to last movie's ending time. So same rule applies here as well. It just now we have K members, so K different movies can be watched at the same time, right? So if you see the input here, the first line has two integers n and k, the number of movies and number of movies, and k being the number of club members. After this, there are n lines that describe each movie. So how is each movie described? With a starting and end time. So you see two integers a and b, the starting and end time of each movie. The output you have to print one integer, the maximum total number of movies. Right, so if the constraint as well here, n and k are less than equals to 10 power 5, and k, the number of members, are less than equals to n. Because if k is equal to n, then like you can say we can watch all the movies, like you can say each person will watch a different movie. Right, so we'll touch upon the example test case and constraints one more time when we discuss this question on iPad. But I guess this question is just a generalized version of movie festival 1 where k was equal to 1. Right, so let's move to the iPad and discuss this question a bit more. First things first, let's talk about constraints here. So n, the number of movies we have to watch, is less than equals to 10 power 5. So it is something like order of 10 power 5. K was also less than equals to n, so k is also order of 10 power 5. So if you talk the time complex in terms of n and you try to present order of n squared solution, it is going to consume about 10 power 10 operations. So this is definitely higher than 10 power 8, right? You cannot do more than 10 power 8 operation in 1 second, which is the time limit for this question. So n squared is out of the picture. Then can we do n log n? Yes, we can do n log n because n log n will be less than 10 power 8. Similarly, we can do n log n, so on and so forth. So we have to do something better than this. Right, let's try to understand this question using the example test case. The example test case is we had n equals to 5 and these are the 5 movies. So one movie runs from 1 to 5, another movie 3 to 6, another movie 6 to 9, 8 to 10, 2 to 5, and k equals to 2. So what does k equals to 2 means? It means we can watch two movies which are overlapping at the same time, right? In the previous question, we could not watch overlapping movies because k equals to 1. Previous means the movie festival 1 question, right? So I hope you remember that question. Fine. So here k equals to 2 means two overlapping movies can be watched simultaneously, right? So the club has two members now. So let's see how can we assign members here. And if you don't forget, a person, you can say, can watch a movie if the starting time is greater than equals to the previous movie's end time, right? So the previous movie that this guy is watching, and if the next movie starting time is greater than equals to the end time, then he can watch a movie, right? So it's different from that room allocation question of this playlist. So here you can say we are starting a new movie inclusive of the end time. That's one important thing. Okay, so yeah, so let's see how can we watch maximum movies. So let's say the first guy will watch this movie, then the second guy will watch this movie. Then we cannot watch this movie because we don't have any more members available, and this guy's starting time is not greater than equals to like this movie starting time is not greater than equals to any of the person who is watching the movie right now's end time, right? So this movie cannot be watched. And then we talk about this movie. Yeah, so this movie starting time is actually greater than equals to one of the guys who are watching the movies right now. So yeah, you can give it any person. Let's just give it the person 1. And now when we are here, okay, this person is free, right? So this person, you can say this movie starting time is greater than equals to one of the person who is watching movies end time. So we can give it the second guy, right? So all in all, how many movies were we able to watch? 1, 2, 3, 4. So you have to print 4. You tell me the maximum number of movies you can watch when you have k members, right? With the rule that we just saw. Okay, so how do you approach this question then? I highly suggest that you watch the video on Movie Festival 1 because we are going to reuse a lot of ideas that we have discussed in that video. And one of them is we are going to process movies in order of end time, right? So we want to process the movie in order of end time. So the next movie that we will choose to watch will be which ends earliest. For more thorough discussion, you can refer to that video, but if you want to see why this makes sense is, for example, let's say we have these two movies to choose from right now. If we choose a movie which ends later, there is a chance that there is a movie which can start like this, so we'll miss this, right? If you choose this movie, then you won't be able to watch that movie. But instead, if you have chosen this, you would be able to choose this movie as well, right? So this is the reason why you should always try to watch the next movie which ends earliest. Okay, and the rule is always there that we'll only watch a movie right now if this guy's start is greater than equals to any one of the guys, any one of the occupied guys. Occupied means these guys are already watching the movie. Occupied guys end time. And so this rule is always there. Fine. Now let's say we like some guys are already watching the movies and a new movie has to be selected. So we want to try to assign a person to this movie, right? So we are processing movies in order of the end time, and let's say some guys are already watching the movies, and since we only care about their end times because you only care if the current movie's start time is greater than any of the occupied guys' end time, we very well need information about the previous guy's end time, right? So let's say some guys are watching the movies, right? So and their movies end here, and currently the next movie that we'll choose right now has a start time of S and end time of E. Okay, and the previous movies may be having end times like this. So like this, and some guys may be having end times greater. Okay, so like this. So of course, when we are trying to assign a member to this movie, we cannot assign any of the persons who are occupied here because these guys end time are greater than these guys start time. But we can definitely try to assign any of the guys who was occupied in these movies, right? So movies where the end time was less than equals to current guy's start time. Okay, so but how will you assign? Like which one of the guys will you assign here? Let's see. So let's say the next movie which ends earliest is this. Okay, and some guys are already watching movies, right? Like this. Okay, and so what I'll do is since we know that these guys end time is less than equals to current guy's start time, we'll just pick any one of these guys and assign them this movie. So this will actually yield optimal number of movies, right? So why do you want to assign a new member here? Even if some club member was free, you would rather pick a guy whose movie's end time is less than equals to current guy's start time, right? But which one should you pick? Now, usually when I'm in this doubt, if you saw in that room allocation question, what I did is I checked what happens if I assigned a movie which is, you can say, a person which is farthest from current guy's start or which is closest to current guy's start. Which one would it make sense? Now, in that room allocation question, it didn't really matter which interval we picked, but here let's see if it actually creates any difference. So what I'll first try to do is I'll try to assign a person whose end time is farthest from current guy's start time. So the current guy's start time is this, right? So this is the current guy's start time. Now what I'll try to do is I'll try to assign a person whose end time is farthest. So I'll try to assign this guy. Okay, fine. So if I try to assign this person, let's say this guy, like this movie ends somewhere here. So that is fine. That's not the point what I'm trying to make. Okay. Now we'll continue processing the movies, right? And you know that the next movie's end time might be somewhere here, right? So it should be higher than this movie's end time, right? So let's say this movie ends somewhere here, and the next movie that you'll try to pick will have end time somewhere here. Okay, we'll have end time somewhere here. Now what if the next movie start time is somewhere here? So it is exactly equal to this. Now what is the problem? You won't be able to assign any of this to person because their end time is greater than this movie start time, right? But if you had this person free, you could have assigned this movie to him, right? But since you chose a guy, when you had an option, you had 3 guys to choose from, right, to watch this movie, what you did, you assigned a person whose end time was farthest. But when you did that, and when the next movie start time turned out to be nearly equal to this guy, so we still process in order of end time, when this happened, you were left with no option. So clearly you missed out on something, right? You clearly missed out on watching one more movie, because this movie can now never be watched, because there are no person whose end time is less than equals to current guy start time. So assigning a person whose end time is farthest is not a good idea. It's clearly obvious here, right? So now let's try to see if assigning this person is the best idea. Let's see what happens. If you try to assign this guy, if you try to assign this movie here, so this person is gone. Okay, now this problem won't happen. Now you know for the fact that the next guy's end times will definitely be greater on this line, Now, even if you have the next guy's start time somewhere here, you can still assign him this, like, if this movie's end start time is earlier, then this person can be assigned, right, which is watching this movie. If this is even earlier, this person can be assigned, right? So what does it say? You try to assign a club member to current movie whose end time is closest to current movie's start time. Right, so what I'm saying is, among all the occupied club members, you will have end time information, right? You will have end time information of their movies, E1, E2, E3, right? You try, when you're trying to watch a movie, right, you will have a start time of it. You try to assign a club member whose end time is closest, right? You try to assign a club member whose end time is closest. Why? Because if you don't do that, you can have a case like this. The next movie start time can be lesser, and you will miss out on watching one more movie. Right? So this is the idea. What you should do is you will try to assign a person whose end time is closest to the start time. Now what if all the end times are greater than equals to, like greater than start time? Then you will try to assign a new club member if possible. If not, we have no option but to skip that movie, right? So if there is a person whose end time is less than equals to current start time, then you can assign that person, and that too the closest one, right? The important word is closest, for the reason we just saw. But if there is no person whose end time is less than equals to current start time, then we will try to assign a new club member, and if we fail, then that movie cannot be watched for obvious reasons. Okay, fine. So, but how will you find the nearest then? Like, how would you do that? How to find the nearest end time? So you have end times stored in sorted manner, and you want to find the closest to this guy. Right, is simple. What you can do is if they are stored in sorted manner, you can just find the upper bound. So upper bound will return one past the less than equals to. So if you have forgotten, what upper bound does is it finds the smallest value greater than current value. So if you find upper bound of start, it's gonna return the smallest value greater than this guy, and you can just go one step back. Right, find the upper bound of S and go one step back. Right, so you can do this. So in this way you can get the closest one. Now, if all of the guys are greater, this upper bound will return begin. So in that case, you can try to assign a new club member, and if there are no club members available, you can safely ignore this movie. So if you want to concretize this, let me write the pseudocode for this so you'll understand it. So first things first, we sort by end times, right? Because we will process all the movies by n times. Then what we will do is we know that we will be able to watch at least one movie, so total will be equal to 1, right? So one movie will at least be watched if n is let's say if you have all the overlapping movies like this and k is 1, you can still watch any one of the movies, so total is 1. Okay, fine. Then what we will do, we'll basically watch the first movie, right, which ends earliest, so that we can add to our multi-set, right? So we'll have a multi-set of n times that we will need. Why multi-set? Because n times can be same, right? So in the multi-set, first we will add the first guy, so interval zeros n time we will add, right? Then so if you want, let's just use one base indexing to interval 1's n time. Then we'll process all the remaining movies for 2 till n. What we'll have to check? We'll have to check if you can say there is an n time existing which is less than equals to current guy's start time, and that too the closest one. So what we can do is we can first take out the current start time and the current end time using, let's say, interval of so this is I, let's say for I equals to 2 till n, so interval of I dot start and interval of I dot end. Now you have to find me the upper bound. Let's just call this IT, which retrieves this ets dot upper bound of current of s, because we'll try to find the closest end time to this s. Now if this it is equal to et dot begin, it means all the end times are greater. So in this case you will try to check if there is a club member who is free and assign this movie. So here what you can do is you can just check if length of et, so number of people who are currently watching the movie is less than k, we can watch this movie, right? So et dot insert current end time and total plus plus. Right, so in this case we can watch the movie, otherwise we cannot watch this movie, we'll have to skip. Else, so if it is not equal to begin, then there is definitely a person who is free. So do it minus minus, so this will correspond to the closest end time, right? So a person who has the movie ending closest to this guy. And what you can do is you can do et dot erase of it and et dot insert current end time, and importantly total plus plus as well, because a movie will be watched here as well, right? And yeah, I mean that's that. So after that you can just print in the end total, right? So yeah, that wraps up the pseudocode. Pseudocode is pretty straightforward. For every, so you will try to process movie in order of n times, and you will check if there is a person who is already watching movie who can watch this current movie, you will assign this movie to this person. Otherwise you will try to assign a free club member to this movie. If both of them cannot be done, then the movie cannot be watched, right? So what is the time and space complexity then, guys? See, time complexity wise, the sorting will consume n log n, right? You will sort all the intervals. Then this is the order of n loop, and in that we are here doing upper bound, which is log n. Erase is log n. Insert is log n. So this is also n log n. So all in all, total time complexity is n log n. Space complexity, we are storing n times in multiset. In the worst case, all of them may have to be stored. So order of n for storing the n times, right? So yeah, I mean that's for the pseudocode. So yeah, I mean let's move on to the code and wrap this video up then. So I hope you understood the explanation till now. If you did, please comment understood in the comment section of the video, and let's wrap up this video. Alright, let's look at the code then. First things first, I'm taking the input. So first line of input was n and k, n being the number of movies and k being the number of club members that we have. Then I'm creating a vector of pair of intervals. So VI is just vector of pair of intent. So intervals is nothing, it represents a movie. Interval of I will represent the ith movie by start time and end time. If you see, so for each movie I take the start time and end time, and then since I want to sort the movies by their end time, I'll actually first add end time first and then start time, right? Because when I directly call sort on this intervals array, then this intervals array will automatically be sorted by the end times, right? So after that I sort the movies by end time. Okay, then we know for the fact that we are going to watch at least one movie. So the total movie that we are going to watch is 1. Then I'll need a set to store all the end times. So this will actually store end times of all the movies which are currently being watched. Okay, so we are going to first insert the end time of the first movie which ends as earliest, right? This is the movie which ends earliest. So we are going to first watch this movie. Then we are going to go through the remaining movies. That is I equals to 1 till n. Now take out the current end time and current start time. Now what we'll try to find is, we'll try to find the closest movie to the current start time, right? So we'll try to find the upper bound of current start time, right? So we know that the closest movie will be it minus minus, but before that we need to check if all the end times are actually greater than current start time. Then in this case we'll just try to assign a new club member, right? So if the number of occupied members till now is less than k, so if there is some club member who is free, we can insert that. We can actually assign that guy to this movie. So ets.insert, so add this guy into the end times set and total plus plus. So we are going to watch this movie. But if all the k members are occupied, we cannot watch this movie. So in other case, the total won't be updated. Else, this is else where there is some person existing whose end time is less than equals to current guy's start time. In this case, we are just gonna remove the largest end time less than equals to current start time. In other words, closest to the current guy's start. So how do you find that? You just find one past the current start, right, and go one step back, right? So we do it minus minus from upper bound. So this will actually point to the largest end time less than equals to current start time, and we can erase this and add current end time and total plus plus, right? So after this loop ends, we would have processed all the movies, and the total will actually contain the answer, the maximum number of movies we can watch when we have k members. So time complexity, I guess we have already discussed. It is n log n, and space complexity is order of n. So yeah, I mean that's about this video. I hope you find it helpful and you got something out of it. If you did, please give it a thumbs up, and I'll see you in the next one.